Hello, in this video we're going to use the method of Lagrange multipliers to maximize product awareness subject to a fixed advertising budget. Here's a setup. The company has $26,000 to spend on billboard ads in Utah and Nevada. The price per ad in Utah is $400 and the price per ad in Nevada is $1,000. The number of people who see an ad in Utah is given by the following equation, where X is the number of billboard ads in Utah, and the number of people who see an ad in Nevada is given by the following equation, where Y is the number of billboard ads in Nevada. The company wants to maximize the number of people who see the ads. How many ads should be purchased in each state? This is the objective function. This is what we want to maximize. Subject to the advertising budget constraint. Got $26,000 to spend. An ad in Utah is $400 each, and an ad in Nevada is $1,000 each. Setting up the Lagrangian. So we have our objective function here, and then we put in our constraint. And you'll notice here I'm bringing over the X and Y over to the left-hand side of our budget constraint. And we're going to take three partial derivatives. The first partial derivative will be the Lagrangian with respect to x. So the exponent on the x term comes down in front. That's why we have 2 in the denominator. And then we're going to subtract 1 from that exponent. And then we have lambda multiplied by minus 400x. And the derivative of that leaves us with minus 400 lambda. And we're maximizing, so we're going to set this derivative result here, partial derivative result equal to 0. And now I'm going to take this expression and solve it for lambda. So 160,000 divided by 2. Following the rules of exponents, I'm going to move this x to the minus 1/2 power down into the denominator. And when we do that, we lose the minus sign on the exponent. And now I'm going to divide through by 400. 80,000 divided by 400 leaves us with 200. And we have our expression here for this equation in terms of lambda. Moving on, here's our Lagrangian once again. Here's our second partial derivative. I said we'd take 3 of them. Here's our second one. So we're going to take the partial derivative of Lagrangian with respect to y. So just looking at this term right here, going to bring the 1/2 down in front. So that's why we got the 2 in the denominator, and subtracting 1 from that exponent on the y term. And then we see this lambda is multiplied by minus 1,000y. And the derivative of minus 1,000y times lambda is just minus 1,000 lambda, and setting this result equal to 0. As before, we're going to solve this for lambda. So 200,000 divided by 2 gives us 100,000. Following rules of exponents, and now dividing everything through by 1,000. 100,000 divided by 1,000 is 100, and we have another expression for lambda. And our third partial derivative, we'll take the partial derivative of the Lagrangian with respect to lambda, and we get back the constraint, what's in parentheses here, also setting that result equal to 0. So we basically have 3 equations and 3 unknowns. X, Y, and lambda are the unknowns. We're going to solve for x and y. So what I like to do is rewrite our 2 equations for lambda that we found earlier, and now set them equal to one another, set lambda equal to lambda. And now we're going to simplify this. Let's cross multiply. So doing that. And the dividing through by 100. And now I'm just going to square both sides. So x to the 1/2 squared is just x. 2 squared is 4. And y to the 1/2 power squared is just y. So this will simplify down to x equals 4y. Now I'm going to plug this result back into our constraint. Here's our constraint. Where we have x, I'm going to replace that with 4y. Simplifying the right-hand side. Simplifying some more, dividing through by 2,600. Y equals 10. And since x equals 4 times y, x equals 40. So this company will buy 40 billboard ads in Utah and 10 billboard ads in Nevada. Okay, I'll stop here.